Hello everyone, this is an update on my, well, I call it my robot arm. You may have seen it in a previous video. I've been doing some updates, had a few issues. The best way to show it is actually in FreeCAD. Let me just turn that on. There. So this is the base, the turret part of the of the arm. Everything's connected to this. Each one of these sort of large discs is one of my hybrid harmonic drive. So each one of these has a motor in it. So there's that one, and then D, and let's have a look. A. These two are linked together. These are just run off one driver because these lift the whole arm. Let me just show you. Turn off FreeCAD a minute. There. If we look at the arm, you can see that that it's linked to the either side of the two motors on the either side of the turret. Let me just bring back FreeCAD. Yeah, so those two drive together, and then these two center ones. This one is for the next section, and then this one's for the next section further on. But I've now decided to use my dual motor drivers. So this driver board, which I'll just show you a link to the web page where it is on PCBWay. Let me just open up my web browser. There. So I've made this new driver. Now this one, what I've decided, the reason for it originally for this driver is I'm also making a track, like an ROV with tracks. Let me just show you that. This is it. Yeah, so that's my new driver for that. The reason I made it a dual driver is so that it controls both tracks at the same time. So when you send one command, it will send that command to both motors at the same time. When I was using my single motor driver, because we were travelling from a web page then to the server and then to each individual motor on the I2C, there was a slight delay between getting both tracks to move at the same time. So I decided to make this driver board so it controls both at the same time. And instead of using MOSFETs, I've used two of these drivers, because if we go back now to my my FreeCAD, I'll just turn the web browser off. Yes, so there's well, we've got 4 motors on top there, but there's also one below as well, which is one that actually rotates the turret. Now I redesigned this harmonic drive to take a slip ring inside, so that all the cables can come up through the middle here into the turret of the, well, mainly it's the power actually, and also it brings the wires down to these two motors. I had to put two motors on this harmonic drive because when I fitted this slip ring inside, I had to reduce the gearing for these planetary gears inside, and so these motors were not, one motor wasn't quite strong enough to turn the turret, and because of this it puts a lot of load on my original driver for this, and it kept blowing me MOSFETs. So what I decided to do was also use me dual motor drivers on this. So now I've added the dual motor drivers. This board drives these two outer motors and one of the inners, and this board drives the other inner and the turret underneath. And so basically this is the update I've done. While I was doing this, I'd forgotten that I used to have an Arduino Nano Internet of Things on here, which is obviously 3.3 volts, but it was on a board where you could input more. It had a linear, well, it had the voltage regulator on there, and I didn't realise that its maximum voltage was 20 volts, and I was sticking 24 in there, so eventually it fried that. So now I've switched over to the ESP 8266 instead as well. I prefer the 8266 to the Nano. I think I didn't really like the Nano, the 3 volt Nano. I think they should have sort of left that as an Arduino Nano 5 volt and everything, and then should have just, when they changed it to 3 volts, they should have just made a new format, the 3 volt format for the new Arduinos. So anyways, that's another thing. So yeah, I just wanted to explain now that I've updated this to the two dual motor driver boards that I've made. Like I say, I've done details of these boards at PCBWay. Where's my web browser? Yeah, so it's all here out to build on PCBWay. There's a project. You just need to click a button and order it, and you can do all the things. There's a video that I've just showed you. There's another video of me actually. Oh, this is a follow-up. I did some live streams. I did three live streams, and I don't know where I've put the links for them. They might be on the GitHub. I've done a GitHub web page as well, and so the live streams will be linked on the GitHub, and it shows you how I put it all together and built it and everything. I think my memory. Well, anybody knows that my channel, my memory is useless. Anyway, so yes, where am I going with this now? Right, so we've seen that, so we don't need to see that anymore. So I will turn off the web browser. So that's that. Yes, so yeah, I showed it in CAD because it's easy for me to turn it around. Basically, I can I can move this stuff around, and it's a lot easier than actually trying to show you on the main thing here. So what I'm going to do is I'm just going to pause. Oh, hang about before I do that. Right, so you can see my little tablet down there. I'll just bring Visual Studio back. So yes, so Visual Studio, let me just get that. You can see I've done the web page is still the same. I've just changed things slightly. So now we've got driver board A, motor 1, and driver board A, motor 2. Can I make that bigger? Yeah. Let's just yeah, there we go. And then I've got driver board B, hexadecimal B. Basically, this is what I've made the I2C address. I've made the I2C address 10 on this first board, and I've made it 11 on the second board. So basically the hexadecimal comes out as board A and board B. Anybody that knows Excel might get that. So yeah, and this is board B, motor 2. So this one actually rotates by actually let's just do board design there, that's it, there we go. So this one rotates, this rotates the turret, this does the first part of the arm, this does the second part of the arm, and I've now got a third part of the arm on. I don't think I had this on the last time. So I will just gonna pause this now and just set the camera up so you can get a better view of get a better view of this, because you can only see the first part of the arm. And what I'll do is I'll just hold the camera, well, it's my phone, camera by hand, and try and just give you some view of it. Then I'll pause it again, and then I'll just try and show you it actually working. So I'm just going to pause. Right, so this is my tablet, which you can see that got me all my controls on. Close up. So these are my I've got that in. These are my little boards. It's all got LEDs for diagnostics. And then we come up and we've got the first arm. That comes up to this connection, comes across to this arm, and then we go down to that arm there, basically. So I don't know. They're all run. It's all got belts from these motors. So there's no motors. There's no motors beyond this point. From this point, it's all done by belts, basically. I don't know if we're getting anything out there. I can't see. The trouble with doing big projects is being able to see it all. So yeah, what I'm going to try and do now is mount the camera so you can see it all in one thing, and then control it. So just bear with me a minute. Oh yeah, you can see underneath. So I've only got the power going in. Basically, because I'm using the ESP, what is it? 8266. It's got the Wi-Fi on it. It's linked to my home Wi-Fi, and then so this is. Oh, it's gone off. So this is linked to my home Wi-Fi, and then because they're all linked together, we can control everything. So okay, let's try that then, shall we? See if I've got everything in shot. Doubt it, but anyways. So here's my controls. I'll just stop it because it's a bit noisy. What I'll do is I'll just send it going round and round. What I'll do is we can move this one back a bit. That way, this way. And then yeah, I'll leave it like that, and then you can just hold on, I just want to pause for a minute. Right, yeah, so I'll just continue now. Yeah, so what I'll do is I'll just leave it like that, and we can now, I'll just put it spinning round in circles. Okay, stop that. I don't know. I should have said, give you a warning. I don't know what the sound is going to come out like on the microphone. Right, so I've got centre on there, so I'll just put it centre. It'll remember how far it's turned, and where if I put centre, it'll take it all the way back to where it was at the start. Go. Listen, I'll come back to centre again. So, is that a good view? Yeah, that's a fairly good view. So, you can see, obviously my first motor controls this one. Stop. There we go. And like I say, you can use a slider to set a position you want as well. And then the other one does the middle arm, so and this one obviously does the new small arm. I've got a floor to put on the end of there yet, so that's still to come. So and let's just lift that way. Stop that, and then I'll press centre on this one, and that one, and that one. Oops! Anyway, I should have. See if I can fix this. I really messed that up, didn't I? There we go. Needs to be within drive. Don't go here, but at least with these drivers now, it's not blowing out my MOSFETs, so it can handle a bit of overload. Anyways, I hope you get the gist of it. I'm going to finish it there. It was just an update of what I've done, really. I just hope you enjoyed it. Right, let's stop it there.